Good afternoon, everybody. My name is John Lucas. I'm from NASA IVNV in Fairmont, West Virginia. I'm just here to talk to you today a little bit about the cryptography library that we've been working on. It basically is extending upon current CCSDS protocols, which I'll get into here in a second. So a quick overview of this presentation. Just going to be really brief on why you should consider using security for your space mission. What is CCSDS? We've heard that mentioned a lot today. I'm not sure of the whole crowd here, but I'll do brief explanation of what it is and what it stands for before going into the protocols that they support. And those two protocols I'll talk about today are the SDLS, or Space Data Link Security, as well as the extended procedures that go along with that, which is actually what's driving this work, which is the cryptography library, which I'll detail there, and talk to you about a little bit of the application, how you would roll it in your current mission, the testing that we've done at NASA IVNV, a quick demonstration, and future work. All right, so why do we need security? Well, spacecraft are extremely expensive, right? The loss of one would be extremely devastating, not only for a company, but for potentially a nation, an organization as big as NASA. So that's something we're definitely trying to avoid, right? There's a big hype right now with cybersecurity, and so that's kind of driving this as well, right? We need cybersecurity. We need to apply those practices on a spacecraft, essentially on the Space Link, right? So the Space Link is actually the connection between the RF at the ground station and the spacecraft itself. That is what we determine the Space Link as defined by CCSDS, right? And so this will be essentially securing that as well as everything that's occurring on the ground, all right? So we can't rely any longer on the obscurity and uniqueness, basically, of our networks, because everything's becoming COTS and becoming really easy and cheap for people to set up amateur networks on the ground and capture your data, manipulate it, replay it to your satellite, potentially gain control and cause problems. And so that's what we're trying to avoid here. All right, so a little bit about CCSDS. People don't usually say it out loud, but I'm going to try to. The Consultative Committee for Space Data Systems. All right, so that's why we just say CCSDS. All right, so they were founded in 1982. Their main goal is essentially the interoperability of different space agencies, right? So there's 26, yes, I'm right, nations that collaborate all together and work together to essentially promote these protocols and standards, all right? And so they have a whole lot of blue books. They've got a really great website out there. If you want some light reading, I recommend you check it out. And the nice thing is that CFS was really developed with CCSDS in mind, right? The software bus that we've talked about a lot today is based upon the Space Packet Protocol. A lot of us just kind of refer to that as the CCSDS packet, right? But that is the Space Packet Protocol if you actually want to see the documentation on that. We've talked about CFDP, COP1, and the TC and TM applications, and the Command Ingest and TO Lab applications, or TO applications themselves. And so our goal here is to really evolve with CCSDS and basically include the security aspect with CFS as well. All right, so a little bit about Space Data Link Security. The nice thing about this new protocol is that it's essentially another layer to your onion of CCSDS protocols, right? So a lot of your protocols already typically have a header and a trailer, and frame data basically in the middle. The nice thing about this protocol is it basically just cuts your frame data down a little bit by adding a security header and a security trailer to that, so that you can essentially roll with any application or anything you've already developed using those other protocols. So it's completely adaptable. Here you can see it basically applied to the TC and TM protocols. Like I said, you got the security header, security trailer for both of those. The only difference is that with TM, you can actually also utilize the OCF, or the operational control field, at the end to essentially get status of your SDLS, Extended Procedures Library. All right, so a little bit about the security header and trailer. So the header itself has a security parameter index. That tells you what configuration essentially you're going to use. More on that later. We've got the initialization vector that's used for all the actual encryption stuff. Sequence number, right? We don't want anti-replay. That's one of the things we're trying to avoid here. Padding length. And then we've got here the security trailer, which is nice and easy. It's simply a CRC. I want you guys to stop me if you have any questions. We're going to get deeper and deeper, so if you have a question on a core topic up above here, feel free to yell out and I'll answer for you. So a little bit about the extended procedures, right? SDLS itself has already been published. The extended procedures has yet to be published, which is what's driving this work, all right? So I'm going to talk to you about that a little bit now, since you can't just read about it yet. All right, so there's three basic things that enables you to do. That's manage your keys, manage your configuration or your SA, as well as monitor and control your essential configuration on the spacecraft. So a little bit about key configuration or key management. It actually is going to enable you to do over-the-air rekeying. All right, and so that's a little bit complicated, but we'll start out by just basically explaining that there's two different types of keys. You have a master key and you have a session key. The master key is only used to upload new session keys. Those session keys are used to encrypt and decrypt all of your data that you're going to be using on your spacecraft. All right, so the OTAR is actually going to be used to upload those new session keys that you'll be using throughout your mission. Oh, excuse me. This is fully scalable to meet your mission needs. So if you have a very short mission, for example, a small sat, you know you're only going to need 5 different master keys. You don't have to waste a whole lot of space having 200 different master keys to enable you to upload all these session keys, right? So that's what's really nice about this protocol. A little bit more about your security association. Like I said, it's fully configurable. You can create a security association on the fly. Say you get a new ground station that you want to add to your network. Your satellite's already in space. You can reconfigure your security association to be able to use that new ground station on your network, for example. This is where it gets a little bit complicated, and which I'll talk about a little bit later, but essentially configuring all of these values to work with all of your ground stations. Monitoring and control. So these are basically simple commands to ensure that your spacecraft's operating as you expect it on flight. We've got the frame security report here, which I talked about a second ago when I mentioned the OCF. This is actually what you'll see. You could use this to debug any kind of mysterious things that happen on your spacecraft, see that something went wrong, like your bad sequence number, a bad CRC value, or an invalid SPI, or an invalid SA that you try to use. So getting into the actual cryptography library that we've developed. All right, it's developed in C. We've kept it as minimal as possible and tried to use it so that we can implement it on both a ground system as well as a satellite. Right? We're using the AES 128 GCM mode block cipher for authenticated encryption. That's recommended by CCSDS standard itself, but we hope to implement more here in the future. We've already applied for the open source through Goddard Space Flight Center. We're just pending approval now, and we'd really like to stress here that it's extremely simple to implement on any protocol you currently have. CCSDS standard basically says that you have to have 2 basic functions, and that is just applied security and process security, and that's exactly what this library gives you. So a little bit about the testing that we've actually done. We're using the cloud and actually testing between NASA IVNV and the ESA, some folks out in Germany. They are essentially the ground station using an independently developed security unit you see here in the red box, communicating via SLE, which is a completely different protocol, about 3 layers up from the standard space packet that we've been talking about all day, over to us, where we break it all the way down, use it in our CFS simulator, running our crypto lib that's soon to be open source, and communicating all data back. So a quick demo here. Let's see if this actually works. All right, so you can see CFS starting up there. I'm sure you guys seen that many times now that you're here. You can see, that's very hard to see, I apologize. But essentially I'm sending commands from the right half of the screen and receiving them on the left half of the screen. The right half is just a simple Python app using CI Lab to send the data in. So first I'm doing a ping, followed by an OTAR to add new keys to the library. I'm creating new SAs and a new configuration to be used as my current ground station configuration. I'm rekeying those to use the new OTAR or the new keys I put on, and then I'm passing messages through to my flight software and pinging again on the new security association. And so those are just a really quick test to basically show you that it is currently working and in use right now in IVNV. So future work, we plan on essentially publishing this standard. That's really the goal of this work. We're currently waiting on CNES to release the final test plan. We're just kind of in a holding pattern until that's out there so that we can test to it and release this documentation, this open source library to everybody. All right. We also plan to include the AOS support and ground system integration testing. Right. So I helped develop NOS Cubed mentioned down here at the bottom. And so we're going to be using that simulation platform essentially to test this from both the ground station side as well as the spacecraft side. We'd also like to do some load testing. Currently we have access to an AVR GOM space computer, the new one, the AVR 32, A3200. And so we'd like to see what kind of load this crypto library is actually producing in addition to our standard CI/TO apps, right? And then we'd like to really improve the separation and explanation. The real problem with the CCSDS standards that I've seen so far is that there's a lot of them, and they're very confusing. So what I'm trying to do with the library is set it up initially so that you could just use it right out of the box, but also provide a lot of explanation as to what changing each configuration option will actually do to your mission, right? And then add unit tests, something you always need. Are there any questions? I feel like I went a little fast, but yes. Oh, get you a mic.
Any plans to enable hardware acceleration for platforms that support it?
Yes, ideally since it is in C, we could run this on any kind of FPGA, and that's really the goal of that process security, applied security as well, so that your application could really reach out over a hardware layer, send it the data, have it encrypted, and just transmit it right out. So that is planned, but not immediately, until we get baseline mode essentially published. So each one of those standards, until I see another question, I'll just keep talking. Each one of these standards, oh, go ahead.
Like the AES 128 is included in a lot of chipsets now. Your embedded
Yes, it is.
chipset. So as long as you call that, you get the acceleration.
Yep. Yeah, so we have a very simple software version of it right now that we're utilizing, just to keep it nice and lightweight in case you don't have that option. But that is always nice to have. Any more questions? All right, well, thank you guys for your time. My email's on here if you guys need to get a hold of me.